Hi everyone. First off, I'd like to thank the IJOA and the IDOA for hosting this conference and giving Cybergenetics an opportunity to present on how we can assist juvenile officers in their investigations when it comes to DNA evidence. What is TrueAllele technology? TrueAllele technology is what we use at Cybergenetics and what some labs use across the country to help dig a little bit deeper into their more complex DNA cases. The lab will tell investigators that the results are inconclusive or uninterpretable. Usually when it pertains to a DNA mixture, Cybergenetics can unmix this mixture and provide match statistics that provide connection information. DNA mixtures account for most DNA evidence, and match statistics, those are what are reported in court. So for this presentation, big numbers mean strong connections and little numbers mean small connections. So let me start with a story. In Pittsburgh, where Cybergenetics is headquartered, about a dozen years ago, a group of juveniles were driving around and shooting at each other for fun. Unfortunately, a police officer was caught in the crossfire. The gun was discarded, arrests were made, and the crime lab said that there were too many contributors. They didn't have any real evidence to push the case further. As we've done almost 100 cases for our county in Pittsburgh and Allegheny County, they sent us the DNA evidence from the case. Our computer TrueAllele was able to unmix the mixture into 4 different DNA components, as you can see, 1 for each person, and comparisons were made. Person A wasn't on the gun, so they dropped the charges, and person B was on the gun, so they pled guilty. DNA revealed everything. The lab couldn't do it initially, and we could. So how can we help solve juvenile crime with DNA software that unmixes mixtures? We can start by solving a simple question. In this case, who touched the gun? To answer this question, or to start answering the question, we need to pull back and get some basic background concepts. Everyone has DNA. You get half from mom, you get half from dad, maybe the better half from mom, maybe the other half from dad. Another aspect here is that people leave their DNA behind. People leave DNA wherever they go. It's just a natural process. For humans, we shed as we live and we move around. Another aspect is that people leave DNA on things they touch. We leave it everywhere. Objects, drinking cups, soda cans, weapons, etc. People are essentially leaving a trail of DNA behind them, which can, in an investigation, provide information regarding where they were, where they are, their position, their location. And those positions and those locations, when tracked, may connect to other items from a different scene and perhaps provide more of an answer as to who left their DNA behind. So just like in the story I told you, this is when the DNA is simple, like 1 or 2 people. So the problem with mixtures is that they can be a lot harder to interpret. Not just 1 or 2 people, but 3, 4, 7, 8, 10, maybe more. The DNA of 1 person is easy to work with. DNA of 2 people is a little bit trickier, and the labs have a little bit more difficulty dealing with that to separate the mixtures up. That's where TrueAllele can come in and help unmix the mixtures, making them easier to interpret. After it unmixes them, it can then compare and then find the people. So we can compare the unmixed DNA to connect it to other people. Evidence to evidence. So like a steering wheel to a phone would be evidence to evidence, or evidence to people, like a phone to a suspect. And we are asking the question, who are these people who are leaving these items? So long story short, you can solve crimes through DNA by making these connections. Real crimes aren't as simple as all that. What happens when there are multiple evidence items and mixtures on those multiple evidence items? They get more complex, so the lab has a tougher time unmixing those mixtures from those different items. But connecting evidence items and connecting them to a person means that you can connect evidence to people through the DNA. So sharing DNA through items and people means you can connect people to their items, and therefore you can solve crimes. So I'm going to talk about a case example that we worked on. It's a really interesting case with very complex DNA evidence, remarkable investigation. So this was down in Ville Platte, Louisiana. Shots were heard on East Washington Street. 2 people were shot, 2 suspects fled the crime scene, and 2 handprints were discovered in the morning dew on a fence post. The night of the crime, one of the perpetrators dies in the hospital. 3 months later, makes the identification and identifies Rokinsky Thomas as a suspect in the crime. The shooting was precipitated by an earlier argument. Shell casings and the bullet was in the victim, and then footsteps on the grass led to the fence post where the investigator ended up noticing the handprints. So this was a really great investigation where it's okay, we see the handprints, let's swab them. Maybe they have something that we can use there. From the fence post, the lab couldn't draw the mixtures in the data. They couldn't draw any conclusions because the DNA was too complex. These were very complex mixtures with dew, moisture, dirt, other debris found in them. So the lab had a very tough time unmixing these and knowing what to do with them. That's where TrueAllele can come in. So you can see on the swab went to the lab put it into the computer tried to get the results, they couldn't. So they sent us the data from the swab and they put it into TrueAllele. TrueAllele was able to get results and unmix the mixtures. Here you can see the data entering the computer and the computer unmixing and separating out those mixtures. And not only that, we could identify people. Through the DNA, you can figure out who is there and who isn't there when you use strong methods like TrueAllele. This is a match table showing what is reported. It's identifying suspects and eliminating other suspects, but it's telling a story. This shows that on the posts, one person could have followed the other, where you see the middle row, which is the post B, is a lot higher than the initial one. But when combined, you're getting both in the hundreds of millions, which is an incredibly high match score. So the DNA and the numbers are telling the story and drawing a picture of what happened. So with the DNA evidence, you're essentially getting the story, the bigger picture. In the courtroom, there was a 7-day trial in Louisiana. The ADA introduced the DNA evidence, and then in March of 2016, the CEO and chief scientist of Cybergenetics testifies in the trial, and on the TrueAllele match statistics like the ones that I just showed you. Both were found guilty because of the connection that TrueAllele had made between the defendants and the fence post. The keys to success in this case, besides the brilliant investigation and the evidence collection, was the lab develops the DNA, the lab sent the data to Cybergenetics. TrueAllele then, with the match statistics, was able to contribute to expert testimony, and we provided the expert testimony, and justice was served. As the prime investigator on the case said, DNA is key. So let's talk about DNA databases. We've established that there are matches and that there are connections between the DNA left behind in mixtures on multiple items. So how are we going to find out who those people are? Well, the answer is you need a reference database. You need a database full of identified or unidentified samples that have people associated with them. And the main point here is that when they're combined, you have a very powerful combination where the items that have pieces of the people on it, and you connect those pieces to the actual reference. So you have profiles connected to the items. So databases like this, the combination of the two, they can store information, they can tell stories. Context and other information can be added down the line, or for the reasons of the investigation, just maintained. TrueAllele databases can make these connections and make them very, very quickly. In summary, TrueAllele unmixes DNA mixtures. Once they're unmixed, they can be uploaded to a database, and then once those are uploaded, you can make connections between people. On the other hand, CODIS can't do that. They can't unmix. So if you can't unmix, you therefore can't upload. If you can't upload, you can't make the connections. And that's why investigators send their DNA evidence data to cybergenetics. I'm going to talk about a case study. In and around the Cleveland area in Ohio, there was a gang of juveniles going around stealing cars over the span of the summer. There were 37 separate incidents and cases that were submitted for testing. So around the Cleveland area, they were about 6 jurisdictions that, in an effort to catch the gang and intervene in their criminal behaviors, they sent in their evidence from the incidents that occurred in their jurisdiction. From the different jurisdictions, 161 evidence items were collected, including swabs from the areas of vehicles, items inside of them, and many of these items consisted of complex DNA mixtures. DNA was taken from the juveniles, including in a gang roundup, where they were able to add, I think, another 30 or so. But now they have the references that could potentially connect the items to the juveniles. Initially, they ran the information through CODIS in an attempt to clear up the story. CODIS had difficulty with unmixing the mixtures. In fact, they returned 30 items to be inconclusive. That was, in fact, not entirely accurate. TrueAllele found that all 30 items actually had a connection to people or items. CODIS also thought that 12 items were exclusions, so that 12 items did not include the suspect on them. That was also incorrect. And it turned out that all 12 items did in fact have a connection to a person or an item. It took CODIS a total of 3 months to return all the results, the inconclusives, the exclusions. It only took TrueAllele 1 month from uploading the DNA to reporting it. Here is an example where the TrueAllele database matched a single suspect across 8 cases in 16 evidence items. So on the left, you see the case. In the middle, you have the items, steering wheels, flashlights, cigars. But for each case, you can see, okay, there's a character in the crime. In the first 3, he was driving. In the 4th, maybe he was... It provides some context for what was happening at the crime scene. And on the right, there are the match scores. From some of the lower numbers, like anything under 5, this is near nothing that CODIS could have ever, that it was probably invisible to CODIS. So TrueAllele stepped in and helped shed some light on the investigation. Much time was used to complete for few evidence connections and inconclusive results, where TrueAllele could step in, and the superior TrueAllele methods, it was much less time, many evidence connections, not just from scene to scene of connecting the different crime scenes, but from scene to suspect, so connecting and people to those crimes. So what does this mean for you guys? Well, increased evidence clarity can lead to connecting reference and evidence or unmixed mixtures into individual DNA. And in the case study, we showed that we can get quick and accurate results from inconclusive evidence, whereas before you couldn't. And it means that stronger leads lead to fewer dead ends, less inconclusive results, and more crimes solved. Probative and reliable DNA evidence, a deterrent, and improved clearance rates for labs and departments. And as we saw, reduced costs and money and time. What does this mean for the community? It means that early identification of repeat juvenile offenders can contribute to an opportunity for intervention. You can stop career criminals by utilizing better technology, fewer criminals on the street, and ultimately better justice through better science. So when the lab says that DNA evidence is inconclusive or too low level, too complex, has too many contributors, these are the key words that you read in a lab report. And they each mean, call me, call Cybergenetics, your lead is not dead, it doesn't have to be dead. Call us for more interpretation power. We can take a second look at your data and come up with some more conclusive results. In short, we can solve cases that the crime labs can't. With DNA cases that have partial profiles, familial mixtures, integrated remains, these are the kinds of things that will stop labs from solving things. We can handle all of these things, and we can handle them very well at a high capacity. So when the crime lab says that evidence is uninterpretable, we can unmix the uninterpretable mixtures. We can upload those mixtures to a database, and we can connect the evidence to the suspects. To learn more about this technology and the power of it, come by my booth. I'm right outside. I'll be there until about noon tomorrow, and you can learn more information. We provide more than database solutions, though. If you have a case during this presentation that you thought of, we might be able to help out with it. We work on individual cases. TrueAllele has been used in over 1,300 DNA cases worldwide. We have won 50 admissibility hearings and have had cases in all but 3 states. We have also helped almost 450 U.S. agencies, including the Department of Homeland Security and the FBI, and we provide a free screening on all DNA evidence with a 2 to 3 week turnaround. So when the lab comes at you with the inconclusive results, once we have that, we can turn around in 2 to 3 weeks and tell you if you're suspect or is in the information or not. All of our analysts are qualified expert witnesses as well, so we'll come testify for you. We'll talk to your soups and chiefs and your cold case detectives. If there are cases that seem to be cold or going cold, we could take a look at that data and possibly turn it around and make it more conclusive and continue that lead. Our last cold case that we helped solve was from 1963. So when we say degraded, we mean like really, really old and degraded. Again, I want to thank the IJOA and the IDOA for hosting the conference and giving me and Cybergenetics an opportunity to speak. Thanks.